Hello, everyone. I'm very glad to see the long list of names joining this webinar. So I am one of the developers of AxisVM, and I will show you 10 new features of the coming X6 version that may be helpful in the everyday practice. It's a kind of warm-up. Later, you will see more technical webinars. Hello, so I'm here. This is the Smart Command Lite function. It's very much like the overall search function in Windows 10. Type something and see that here you find a wide range of commands, settings, and display options. It's especially nice for the beginners who don't know where to look for things. The search function is available in all supporting languages. Let's see some examples. I will show German, Dutch, and Polish, but of course I didn't want to show all the languages. Of course, it's in Italian, in Serbian, Czech, so all our languages is available here. That's the Dutch example. Then the Polish. So if you have no idea where to look for a certain setting, start typing a possible keyword and see the results. For example, where can I set drawing of projection lines to a work plane? It's a display option. I start type the projection, and then a yellow marker will help to find the control related to this function. Okay, you can turn on and off graphic symbols and labels without browsing the dialogues for the proper checkbox. So it may be faster than browsing the dialog. You also get a wide range of selection functions. Click on the magnifier icon and choose selection based on one criterion. See some examples. The asterisk is to select all. With the minus, it's to deselect all. You can use it with slabs. As you see, the matches you get in the list box are those functions that can be used for selection. So, for example, we can filter by domain thickness. You can enter the value and you will get the selection. You can use multiple criteria, follow the blue instructions to enter the filter conditions. For example, we select walls that less than 20 centimeters thick. You have to type the filter condition, then press enter. If I press enter, I apply the filter. The same with the cross section. Certain columns will be selected. It can be length of line elements, for example, beams. So we see at the top these beams. We have also other functions related to the selection, like show only selected elements. you can reach these functions here as well. So with the asterisk, we can select certain material and length. We can combine as many criteria as we wish. You can use 3, 4, or any number. Let's go to the static tab to select elements by result value. For example, we want to check elements when a normal force falls into a certain range. It's a downward force, so if it's below minus 1000, it's a very big value. But we see that certain columns have this huge normal force here. We can combine multiple criteria, so we can reduce our investigation to only certain profiles where this value appears. And then at the bottom, we have the proper columns selected. We can do similar search function within the preferences dialog. So it's a settings menu and preferences. So we can type keywords and find the settings within the dialog. For example, undo levels. The similar functionality is added to the keyboard shortcuts dialog, so you don't have to go through the categories finding what you need. You can just type the keyword directly. For example, load split functions. The next issue. We have special window layouts predefined. These layouts divide the work area into viewports and set the view in each pane according to a scheme. Layouts are predefined so that you can retrieve these settings quite fast. It's another example. It's a structure in the XZ plane, especially for beam structures. And this functionality is also available when doing a reinforced column design. These are additions to help work with special domain types introduced in, as I remember, X6. So we have parametric ribbed domains or hollow core domains. These are available in the auto-created automatic parts and can be used to filter the selection. So we constrain the selection of certain type of domains. We can set a selection filter for hollow core domains. And we can use the smart command line to do the same. and for the hollow cores. It's another small issue, fine-tuning graphic symbols. Version X6 allows fine-tuning of further symbols. First, we create a shortcut. It's also an example of using the search function. So now we have a Shift-Control-G for graphic symbols, and eccentric beams are new in X6, and the display can also be adjusted. Coronal and line size can be set both for the center line and the logical axis. This is the thickness of the line, and this is the color of the line. And separately, we can control these parameters for the logical axis of beams. That is the line connecting the end nodes. Some other examples, for example, the size of end release symbols can be adjusted. It's among the element properties. This is quite a big symbol in orange. Let's see. Here we have the new symbols. Something similar for the edge hinges, which are elements. So we can find them under the elements category. It will be a very big symbol, but when you look for edge hinges, you will see them and find them in a big model. You can also customize the size of labels and their color. So for example, for the node numbers, size will be reduced. The beam numbers will be larger in green. The cross-section name will be blue. That's it. If we have a multi-story building, the structure grid is not always the same on each story. In this example, columns must be placed to different positions on the top slab to support a lightweight roof, so the grid used on the ground floor can be a good starting point. In X6, you can copy a grid to another story or to any position. Now we copy from the ground floor to the story 5. We see the copy, and we go to story 5 to adjust the grid. Now we are on story 5. We click on the grid to adjust it. We can rename the grid, which is much nicer to call it grid 5. And we can change the labels, the prefixes, anything. Now here I will override the spacing for X and Y directions. So it will be a completely different grid. As you can see, the nodes, the top of the columns are not on the new grid. So we can place columns at the intersection points. I could have renamed the grid lines, for example, from L to another letter to avoid mismatch. But now we see that the grid is different on the top story, and I show another type of copying when we move the grid by an arbitrary vector. So you can shift the grid horizontally or to any position. So you can specify the offset vector the usual way. So now I will shift one story down. I will override the grid settings. I modify it. So now we have a third type of grid. That's it. This video tells a story about detecting modeling problems. So when do we detect the errors? The sooner, the better. This is an example, a simplified example. We have a model, we meshed it, go to the static tab, do the calculation. We got the results, everything looks okay, but when we check apart only the walls and set the range, the color range to the range of the active parts, we see that something went wrong. So we have to fix the model. We have to find the problem and fix it. We could have made this check before. So we can select free edges. This edge is free, it's okay, but the other one should not be free. It's at the intersection of the wall and the slab, and the wall does not reach the slab above. You can see it only if you zoom in. That's the problem. So we have to correct it, go back to the geometry tab, move the node to the proper position, and at the other end of this wall, same. Okay, now fix the geometry. We have to mesh the domain again and check it. Okay, now the free edges can be found only at the outline, the outer boundaries. We have a new analysis. Let's check again the walls, setting the color range to the range of values within the active parts. It's much better. A splitting loads function was introduced in X5, but in X6 we have two more splitting functions to speed up the work. First, we define loads, which we will split by stories. So we place the same load on each slab, drawing the rectangle backwards to select the intersecting domains. We set the desired load. Then we create a load group for the generated load cases. We'll call it live.stories. Okay. Then we split the loads of the ground floor according to the structural grid we have. That will be the second issue. Now we just split these loads, placing them into individual load cases. As I check that, remove the loads from the current load case, the loads will disappear. But if I go to the newly generated load cases, we see that we have 4 load cases with loads on the individual stories. Now we display the ground floor only to show the other function when we split loads according to the structural grid. We have two types of splitting pattern, field by field and the chessboard pattern. We create load groups for these. So first we will check, we enter root for the generated load case names. We place load cases to this load group and set the chessboard pattern. And let's check it. We go to the ground floor 1 and ground floor 2. So these are complementary patterns. We can check it if it's if the all of the domain is covered. We can check it by setting special color coding for this type of loads. Okay, everything is covered by loads. If so, overlapping loads would appear in the color coding. Now we do the same, but in this case we split the loads field by field, so we will have as many load cases as fields. That's a greater number. So we generated as many load cases as the number of total fields. This splitting can also be checked using color coding. This part shows how to change multiple loads with the same intensity in one step. That's the question. We have same loads on certain elements and we want to change the value on all elements with -3. So we select the component, extend the selection to the same value and change to -4 to -4. That's it. In one step. We do the same with the inside purlins, -6, extend the selection, change it to -9 on both ends. That's it. It's the fastest way to do this. For concentrated beam loads, it works just the same. We extend the selection and replace -2 by -3. We select inside purlins -6 to -8. And it's much the same for surface loads. We select one, extend the selection and change the value. This is the last video. It shows how to control the transparency of load panels in X6. This is an example model for wind loads. We go to the rendering options. It's a new control here for the transparency of load panels. We go to the opaque and go to the transparent direction to the other. we come back to 40%.